Ladies and gentlemen, good morning. Welcome to this third day of the conference. I'm Marco La Peña from University of Naples, Federico II, and co-chair of the conference. And I'm very happy to introduce the main speaker of this morning, Giuseppe Coviello. Giuseppe Coviello is an ambassador of the Neapolitan excellence in the world. He is an alumnus of the University of Naples Parthenope, and he currently works as a researcher at the NEC Laboratories America in New Jersey, where he spent a large part of the last years finding solutions to improve real-time analytic applications for public safety, transportation, and healthcare. Thank you, Giuseppe.
Thank you for the presentation. Continue to that. Thank you for joining this talk this morning. I'm a former student of this university, so I'm very happy to be back home and give this talk. So before starting on the actual topic of the talk, I want to spend a few minutes to talk about my workplace, NEC Laboratories of America. Maybe not everybody knows today about NEC Laboratories of America. We are an R&D, actually a network of R&D labs to support NEC business worldwide. We have laboratories almost everywhere in the world. We have obviously Japan, NEC being a Japanese company. We have America, that is where I come from, and we have Europe, Israel, China, India, and Singapore. Hopefully at some point, not so, at some point in this life, we will see also NEC laboratory in the Mediterranean area. So our purpose as a R&D lab is not just to support the business of NEC. NEC is a company that is old enough that can not just pursue profit for profit, but NEC nowadays wants to pursue the profit to improve the life of everybody in the world. This is the vision of Yamada-san, our Senior Vice President of NEC and Director of R&D. His vision is that we have to make useful technology, build useful technology that is not just useful to improve NEC profit, but to improve the life of everybody in the world. But let's talk about data. Let's start from the origin, more or less. This is a calendar. It's an ancient Egyptian calendar. It's called the Com-Om calendar. It is something around 4,000 to 5,000 years old. Why this is important? This is important because it tells us that humanity, since the origin, had been always collecting data, analyzing, making observation, and deriving some high-level information. So this calendar, which I don't understand very well how it works, but trust me, it's a calendar, and they divided the year in 12 months of 30 days each, and the 5 extra days are just for holidays. And they derived to this observation, so to make a year of 12 months of 365 days, by observing the cycle of the river Nile. Of course, they were there. They were always looking at this river, how it's flooding, and they derived this information. This is very useful. Not just interesting, but it's useful. It's useful because using that data, they could organize the agriculture. So they started from the observation there per month, and then they divided it in 3 seasons. There is the season for seeding, planting, the season for growing, which is when the river Nile will flood, and the season for harvesting. So we can, by organizing the agriculture from observation and from data, the Egyptian civilization could grow, and probably we wouldn't have the source of the pyramids. It is data, observation, and analyzing the data. But that calendar was built in 2500 BC, and they kept using the same calendar again and again and again to organize agriculture. It worked for so many years, until there was a famine of 7 years, because there was a small shift in the time of the year when the flooding of the Nile started. Because of that, thousands of people died of famine, which means that, yes, it was useful to use data to organize the agriculture, but it's not that good to keep the same data to make the decision again, again, and again. So, what is the solution? We would need more data. We would need more different sources of data. We cannot just observe the river. We should update it more often. Indeed, it's what we did. Nowadays, the agriculture is heavily based and organized on observation, on data, on multiple sources of data. We have, of course, the weather data, and then we have a lot of sensors in the ground, so we can measure the soil and all the metrics, how much sun is there, the wind, and so on. So today, the agriculture is heavily based on data, more or less similar to what the Egyptians used to do. We just have more data. We react to the change of data quicker than the ancient Egyptians used to do. That's why we have, almost in this part of the world, we have no problem in growing food anymore. And we are not done yet. This is the future. The future, we will be able to not just measure everything, but also react instant per instant and plant per plant to the change of environment, to how the plant is growing. And this future is near. It's not that far. We have this facility is in Israel. They are growing indoor strawberries. Actually, this is not today. This was 2 years ago. So, what we learn from the ancient Egyptian to the future or present, that the volume of data that we use and we need, it kept increasing and it keeps increasing. The complexity of the data also increases. At the beginning, we just have to observe probably the river, we might observe the moon, and we can make a calendar and organize agriculture. Today, we have tens of sensors on each field, and then in the future, we will have sensors, 3, 4, 5 sensors per plant. Each plant that we grow will have sensors. So the complexity of data increases even more than the volume. But the time that we have to analyze this data and to react to the change of this data is going down. So this is the challenge of today. More data, more difficult to make a sense out of it, less time to make a sense out of it. And that is not just in the agriculture, in food. We have exactly the same in several other fields. For example, and these are the fields where I have some familiarity: the healthcare, the public safety, transportation, housing, and so on. So what is the trend that we see in all this field? That in the past, the quality of the outcome depends a lot on the experience of the operator. So, if we look at the healthcare, the outcome of a surgery depends a lot. It depended a lot on the experience and the ability of the surgeon. But today, and even more in the future, we can put the experience of all the surgeons together, and we will be able to guarantee the same kind of healthcare for everybody in the world. They don't have to seek that surgeon because the experience of all of them, it is codified and can be utilized. So, what do we have? It doesn't matter if it is agriculture, if it is healthcare, if it is public safety, or transportation, or housing, accommodation. We always have sensors that produce data continuously. This data needs to be analyzed, put together, and with that we can make decisions. This is actually NEC business. In all of these fields that I showed you before, NEC has products, has solutions that have been deployed, and I cannot either deny or tell that I've been part of this kind of product. So we do have products in the healthcare that use data to improve cancer diagnosis, in the agriculture to improve the cereals kind of growing, and then in the accommodation, in the industry, in the public safety, and in the transportation. So, what do we want? Of course, we want that the applications are easier to build. We don't want to spend so much time to build applications. And we want to reuse applications as much as possible. And we will see later that that is a thing. Why reinventing the wheel again and again and again? But, and this is something that being from probably who has more experience in the industry, that deployment and maintenance, sometimes it's even more difficult than the initial implementation of an application. So, I have a solution for all the three of them. So this is our solution. This is a platform that finally, after a few years, I can finally talk about in public, that provides a solution to easier implementation, reutilization of application written by other people, and make it much easier to deploy and to maintain data applications. And it is based on for technologies, for principles, which are abstraction, monitoring, auto-tuning, and a service mesh. Let's talk about abstraction. So, when we think about or we describe a sensor analytic application, we say we have sensors, different kind of sensors, and this sensor produce data. We run some analytic on this data, we derive information, and we can run automation. That is how we describe it. That is when I talk to management in my company, I will describe it. Very simple. Reality, of course, and you know it well, it is not so simple. Yes, we have sensors, but before even looking at the data coming from those sensors, we have to decide where do we run this analytics. If we use edge device, if we use on-premise servers, if we use the cloud, if we use combination of those. I'm sorry, my homemade solution is not that great here. So, and no, I think it's the battery, guys. Are you sure it's not the battery? Okay. Okay. So, I'm sorry, la batteria. No, they say that it's my older solution that doesn't work, but I think it's running out of battery. Let's see. Va bene. They say it's good now, so I have to hold it. We have to decide which kind of hardware, or which kind of computing platform we want to use, edge device, on-premise servers, or cloud. We have to decide how to transmit the data to the computing device. Then, after we do build the application, when we go and deploy them, we have to decide, and we have to organize how do we assign computing resources to those analytics to be effective. So it is a lot of more work to do for our Egyptian friend here that has to build the analytic application that he wouldn't like to do because it's a register the sensors, describe the analytic application and nothing else, and how they are connected from a logic point of view. It will not tell how they are connected. It will not, doesn't have to describe which kind of computing resources are needed. So, and DataX will take care of running and guarantees the best performance. Next, very important, of course, is monitoring of the hardware platform, and this by itself, it's already a big help for the deployment, for the development, and it comes out of the box using DataX. So yes, we don't need to go SSH in the node, use stop, use free, try to make a sense why this node is loaded more than the other one, and so on. But since the applications are built using the abstraction that we saw before, DataX will provide out of the box monitoring of the metrics that make sense of the application. So we can see, you can show the whole pipeline, how it is performing. We can easily spot a bottleneck here, if there is. And we can see each one of the analytics unit. So, how is it performing? For how long is processing? For how long is waiting for input? How much data is producing? Next important part of DataX, and it is the auto-tuning. This is very important for the success of DataX, because historically in the lab we have very good machine learning researchers, now they're called AI researchers, which produce very, very good and very accurate analytic application. But it is very difficult to bring them to the market, to deploy them in the real, for real customers, because it is very difficult to organize the tuning of those applications. DataX does it automatically and for free. The auto-tuning, as you might, of resources, it is comprised two kind of, it's two technologies. One, it is the scale out, or in other terms, how many copies to run of each, or how many instances to run of each analytics to produce the best results. And here, if we compare, or we start from a simple use case, from a simple solution, which are those provided by Kubernetes, which are basically they will just assign more resources to the application that utilize more resources. That is something a model that works for Google, but there is one Google in the world, and it can work for smaller deployments. So that's why is he still working? Oh, okay. Because sometimes I can hear myself, sometimes not. So okay. So we have a different solution for auto-tuning, where we can look at all application, and we utilize some machine learning kind of technique, reinforcement learning in particular, or some other algorithm to produce the scaling out of the application. And we show that for application that we do use and we sell to customers, we have a good performance improvement with using our auto-scaling mechanism rather than the stock Kubernetes mechanism. Probably a 30 to 40% improvement. But the next, and even more difficult, it is to assign the resource in terms of how many cores, CPU cores, how much memory, to allocate per each instance of the running analytics. This is something that Kubernetes does by itself very badly. Nobody uses it. So even though Kubernetes will take care of running your application, will take care of moving it to a different node if a node fails, the deployer, it is responsible to exactly tell how much CPU each replica, each instance needs to allocate, how much memory. I know this is something that in the HPC world, it is common. This is something that can kill an enterprise application, because the deployer doesn't want to do it. But we have a solution for that. We have an allocator that dynamically changes the resource allocated to each analytic unit, and it does it as the analytics happen. And why that is important? That is important because how much resources are needed for each stage of the analytics pipeline changed based on the content. And we have seen in our results that our auto-tuning for the allocation of resources will give results that are performance improvement about 3 times what Kubernetes VPA will do. Finally, we say that we have all these analytics that are connected in a pipeline. We have said that we can decide automatically how many copies to run of each one of them, how much CPU, how much memory to assign to each one of them. But we haven't yet talked about how they are connected to each other. And of course, you know that is very important. DataX does it, so the data scientist doesn't have to worry about how they are connected to each other. It just will say, okay, just grab the data from this analytics, and then I will produce some different analytics on that. So, if we see the state of the art when it comes to this kind of microservices, how they communicate with each other, we can have a service bus-based mechanism where everybody connects just to the service bus. They will emit their output data to the service bus. Whoever is interested in that data will subscribe to the service bus, grab this data, do their own, perform their own analytic, send the output on the bus. This is very very simple to start with. It is very easy to add new application. The data is always transmitted on the bus. If we want to build a new application that utilizes some of the pre-analyzed data by different analytics units, it's very straightforward. Of course, it is very flexible, but it utilizes a lot of bandwidth. And we cannot very well, and this is important for real time, we cannot very well guarantee the real time when we use this kind of communication. The way is obviously is to use it point-to-point, so each analytics knows which one is the following one, we'll just send to that one, and so on. Problem is that when we scale out, and when we run multiple copies, we have to take care of that as well. And we have to use right away the new one. There are some out-of-the-box solutions for this problem, which work fairly well, but not as well as we would like. The DataX provided service mesh will actually provide a semantic that is very similar to the bus. So a new analytic can just subscribe to the input that it needs, but under the hood there is a point-to-point connection, so we don't have a broker in the middle. So the analytic will, under the hood, connect directly to the input, and this provides a boost in performance compared to the bus-based mechanism, but will offer the same kind of flexibility. And actually, sometimes it provides better performance of an out-of-the-box, state-of-the-art solution based on point-to-point connection using linker as a service mesh. So, now to finish, I want to talk briefly about this game that unfortunately I was not able to bring here. It's a bit too heavy. So this is to showcase some of the analytics. This is not a showcase actually of the platform of NEC Labs. So this is a golf playing game, a game, and here we showcase which is one of the strongest analytics of NEC, which is face recognition. With that, we show other human-based recognition, which are what we call the human attributes, the clothing of the person, the hair color, if the person has hair, and so on. Also, the pose and the mood of the person. They're all here. And other higher level analytics that we can see here is that we have technology that we can feed the proper way of performing an action, videos of a proper way to perform an action, and then later on it will analyze real-time videos and will provide a human readable comment on how that action was performed. So what we do here, we have someone playing at disc golf, and this analytic will tell, your shoulder were not in the correct position, or your knees were not in the correct position, or you moved too fast, or you moved too slow. This was a showcase of the analytics, was not a showcase of the application. And we showed that Identity Week in Washington, D.C. We showed it at Open House, NEC Open House in Tamagawa, Tokyo. And this is how actually the application, it looks like inside. We have several sensors, several analytics. They are connected to each other. And we have a UI at the end. This looks complex, but this is not even as close as the complexity of running it on real application. But what is the powerful message that I want to give on this demo is that all of this big demo application was built by different entities inside NEC, which not all of them know each other. And each one of these components was built, developed in different parts of the world. Some of them were built here in this university. Some we built in our lab. Some were built by different labs in Japan. And the people that have built these analytics, they don't know each other. But they could do this, they could achieve this, because they use the common platform. So, this is, in conclusion, what is DataX? DataX is a platform for real-time analytics. The benefits of DataX, in a summary, are a faster time to market, because the developer doesn't need to worry about so many problems. DataX does it. Makes it much to collaborate, which is very important. Of course, it will reduce the hardware requirement, since it can improve a lot the allocation of the resource for providing better performance, and it reduces the maintenance effort, because if everything is built on the same standard platform, who is maintaining a deployment just needs to learn that platform. And that's it. Thank you very much. But before that, well, that ended the presentation. I wanted to add a message from NEC Labs. I wanted to say that we are hiring, so full-time internship. If you are interested, just talk to me.
Thank you. Thank you, Giuseppe. Very inspiring presentation. There are questions. Yes? Excuse me? I mean, because you, at the beginning, you told us that your goal is to make life easier for the mankind, for people on the earth. So, if you would like to try it at a university, for example, so
Yes.
yeah.
Yes.
So it
okay. It is not open source. Unfortunately, it is not open source. I cannot say many things. But yes, 100% we can work with university, of course for free. We can provide license for free to university. Let's talk about the application. No problem. This university obviously uses DataX.
Thank you for the very nice talk. I know that NEC, at least in Europe, as a research center, they are also dealing and developing lightweight virtualization solutions, such as the ones based on unikernels and things like that. So I was wondering if there is any interplay between the two. So on the one hand, to improve the quality of balancing and throughput maximization together with the aspects related to lightweight virtualizations. Thanks.
No, actually we don't have any collaboration at the moment with Europe. I know it seems weird, but we do not integrate the solution together now.
Just some curiosity. Do the platform support all kind of distributed computation? I mean, edge computing, fog computing, or and cloud computing, or is specialized for cloud computing, for example?
Oh, no.
Very often, sensors and actuators are very close. So, in order to reduce the data movement from sensors and gadgets.
Actually, really we can use just edge, just on-premise, or just cloud, or any mix of this kind of computing platform. We do have some deployed solution, which they use very tiny edge devices. They actually Raspberry Pi put in an industrial strong case, and then we that basically just connect to sensor, get the data, and transmit to some slightly bigger edge devices. And then every once in a while, these edge devices will, these bigger edge devices transmit to the cloud. So, and all of that happens inside DataX. So whoever builds the application just sees, okay, I will have the sensor, I have this analytic that basically process all the data from the sensors, but produce less frequent output. And then we have some other analytics that will make some further processing. And these are some on the very, very tiny edge, some on this bigger edge machine. They are the computing capability of a desktop. And then there is some cloud instances as well. So any kind of mix and match is possible.
Thank you. More questions? Okay. Thank you, Giuseppe. I think that we can close the session and enjoy the breakfast. Thank you.